Welcome everyone to another problem session. So in this problem comes to us again from Indian JEE 2024 Advanced Phys Paper 1. We are doing this, and then once we're done with this, we're going to do paper 2. Now this is a question in thermodynamics, and this is a new section. Question 13. Before this was in the other section. In this section, you have like 4 questions based on one setup, and then there can be multiple ways can be they're mapped. It's like only one of these would be right. Okay, so like if A is right, then P is to 1 and Q is to 3 and R is to 5 and S is to 4. So this will be like A. And similarly, you can see there will be for the B, possibly V, possibly C, and things like that. You can probably have some strategy. You can figure out like, okay, which one of P, Q, R, or S, which one I should P, Q, R, or S, which one should check first? Well, you can see P kind of has 1, so 4, 4, 2. So if you can rule out 1 and 2 and for P, then it's only C or B or C. If you land on B and C, then you can say Q can be done. And similarly, you can do it for other things. So you can look at which question you can do right away, and that will help you kind of rule out things quickly. That will be my strategy. Anyway, so that depends on the question, right? So the question is 1 mole of, so you have 1 mole, so and it's ideal gas. So we already know is PV equals to RT because N equals to 1. And gas is going through the cyclic process. And normally you write PV diagram, but this is written as PT diagram. And that makes it really simple because that's one equation per state. And second thing you know is ideal gas has internal energy 3/2 nRT. For 1 mole, it will be 3/2 RT. So energy, like over here and here, temperature is constant, so energy will not change in M to J. So like change in internal energy of gas in the process M to J will be 0. So I'll do S first because I know the internal energy questions will be really easy to do. So in this process M to J, temperature is constant. So delta U Mj will be 0 since delta T equal to 0. So let's see which one it rules it out. So S goes to 2. So S goes to 4. So this can be still alive. This can be still alive. So these guys go away. So now I have to see which one will distinguish more easily. I can do R 2 or 5. I can do Q 1 or 3. But this thing actually is not helping at all. So I don't have to do P at all. Okay. So let's see which one I can do more quickly. Another internal energy question. Let's do Q. Change in internal energy of gas in the J and K. Temperature is changing. I just use this formula. So delta U J to K is U at K minus U at J. And U at K is going to be, both of them have 3 of R. T at K is 3T0 minus T0 is equals to 3R, because this is at RT0. 2T0 and 2 will cancel as 2 and makes it 3RT0. So we find that Q goes to 3. So Q goes to 3. So this is the answer. So the answer is B. But if you say, did I make any mistake or something like that? So you may want to work it out. Heat given the gas in the process K2L. K2L. K2L, you have to figure out pressure is increasing and the volume will be different also. So you have, so to K2L, heat exchange will be so delta U 0 because temperature, so and Q minus W, so this is 0. So Q will be equal to W, and I need to find out the work. So that's how you can solve if you wanted to check with Q. But you don't need to check with P because P is not distinguishing. And once you've done already this much and this simple one, you can just move on. I'll just leave this as an exercise for you. Okay. So you can work it out. This is a constant temperature. So if you I'll give you a hint and then you can do it. If you do this PV, so pressure is increasing, so this may be a K, and temperature is same, pressure increasing, so this is K. So this will be an isotherm at temperature 3T0, and K2L will be like this. So this is 0, 0. So this is the area you want. So that's the work. Work will be the area under this. So if you can do PDV, or you can just convert. Yeah, this will be like a integrate minus PDV. Okay, and then you should find out the work done here, and that will be one of these answers. So it is saying that it should be 3. No, the work, the heat R is 5, so it's going to be something like that. I can already see this. You can convert P is R times 3T0 over V dV, and then this will become a log, and then you can figure out what's the volume at K is and volume at L is. Okay, so this is for you to do that task. That's it for this problem. We already solved this problem, and I will do another problem at another time. So see you in another video. Okay, bye.